Hello and welcome back. First of all, I would like to thank you for supporting me in doing this good job. I want you to know that I always try to bring accurate and clear information to you. The sole purpose of me creating these videos is to help you understand those concepts that you always wanted to learn. At the end of this video, if you find it helpful, please do like, comment and share. If you are new to this channel, also hit the subscribe button in right bottom corner. With that being said, let's see what we have got today. In today's video, we will see about weight message 4. What can be the possible reasons that you see your ASA stuck at weight message 4 and how can you fix it? So let's get started. Before we go into why we are at weight message 4, let's go a little back and talk about what information is shared in message 3 and 4. Right. First, let's understand what does it mean wait message 4. So we have an initiator and we have a responder, right? Initiator sends first message. After sending first message, now this guy, he can wait for message 2. So initiator can be in a state wait message 2. After sending message 1, he can be on wait message 2 state. The responder receives message 1 and sends back message 2. So message 2 is sent. After sending message 2, the responder can be on a stage. Now it has sent message 2, so it is waiting for message 3. That's what will be the stage, wait message 3. Initiator has received message 2 and initiator will now send message 3. So after sending message 3, initiator can be in a stage. It will wait for message 4. So wait message 4. So now initiator has sent message 3 and it's waiting for reply. If it stays here at wait message 4, if it just stays here, that means it has not received message 4 back. Before we talk about why it is at wait message 4, let's understand what information it has sent in message 3 and what are they going to do next. I've already done another video on what information is shared in message 3. A quick recap. So in message 3, we sent key exchange payload. In key exchange payload, it sends Diffie-Hellman public key. Next thing we send is nonce payload. And next thing is netd. So netd is your net discovery. These three things are sent in message 3. Now about the possibilities. What is the possibility that initiator is stuck at wait message 4? Why it is stuck at wait message 4? Any thoughts? Is it possible that some other device here, maybe a router, is blocking this message 3? This message 3 is not reaching to the responder. Is it possible that someone here is blocking it? Well, if your answer is yes, let's see. These all messages 1, 2, 3 and 4, they are exchanged on UDP port 500. If this router is blocking UDP port 500, then how was first message allowed? So if you are saying that message third was blocked by any device in between because the router blocked UDP 500, how did it allow the first message, right? If the router was blocking it, it would have blocked the first message as well. It means this is not correct. The router, there is no other device blocking it. Maybe the third packet is reaching here. The responder is even replying back, sending the fourth message, but the fourth message is not getting back to us. So it's being dropped somewhere here. And what are the chances for it to be dropped here? I would say 0, because again, fourth message is also on UDP 500. So if there is any device in between that is blocking UDP 500, it would have also blocked message number 2. But that did not happen. So that means there is no device that can block message 4. So are we good here? Does it make sense to you that message 1 and 2 is allowed and then third and fourth is being blocked because some device is blocking UDP 500? When I'm telling you that all these 4 messages, they are exchanged on UDP 500. So if third packet is getting blocked, that means first was also being blocked. If first message was being blocked, how did we reach up to third message, right? If the first packet was being blocked, then this would have never got any forward, right? Initiator, responder. Initiator sends first message, responder sends second message, initiator then sends third message and goes into a state wait message 4. A third message, it sends key exchange payload, nonce payload and netd. Let's say the responder has received third packet. Now I need your attention here, a complete attention. This is very important thing. So listen to me carefully. If the responder has received third message, what will it do now? It will send fourth message back, right? If the responder successfully sends fourth message back, now what will the responder do after sending fourth message? It will wait for fifth message and it will also start preparing for sixth packet. If you remember, after sending fourth packet, both initiator and responder, they do some calculations independently. So let's say responder has successfully sent fourth message. It came back here, initiator received fourth message. Now they both will be doing some calculation on their end independently. What will be that calculation? Initiator here will generate session keys and responder will also generate its session keys. And they both will be doing this thing independently. So the moment responder sends fourth message, it will start creating session keys. The moment initiator receives fourth message, it will start creating session keys. How these session keys are generated? To generate session keys, first of all, they both calculate Diffie-Hellman shared secret. So initiator calculates Diffie-Hellman shared secret on initiator end, and the responder calculates Diffie-Hellman shared secret on responder side. Once Diffie-Hellman shared secret is calculated, now they will create session keys. So to calculate session key, the formula will be something like nonce Diffie-Hellman shared secret and the pre-shared key. So same thing the responder uses here. So it uses nonce Diffie-Hellman shared secret and pre-shared key. So after sending 1, 2, 3 and 4 messages, they will start preparing for fifth and sixth message. Both the sides, they will do it. The moment responder has sent fourth message, responder will start preparing session keys. To prepare session keys, we need Diffie-Hellman shared secret. So they will first calculate Diffie-Hellman shared secret and then using the Diffie-Hellman shared secret, nonce and the pre-shared key, they will calculate session key IDs. So if you notice, pre-shared key is necessary here, right? The responder has to know what is the pre-shared key. Same way, the initiator needs to know what is the pre-shared key, right? Where is the pre-shared key stored? It's in the configuration. On both sides, they have configured pre-shared key, right? So they need to pick the pre-shared key from the configuration on the ASA. And in what part of the configuration do we store pre-shared key? Where do we, enter pre-shared key in the config part? Initiator, responder. The pre-shared keys are stored in tunnel groups. So let's say initiator's IP address is 1.1.1 and the responder's IP address is 2.2.2. The pre-shared keys are stored in tunnel groups. So in initiator side, I'm going to give it a different color. Initiator, responder. So the initiator will have a tunnel group with the name of responder. And in this tunnel group, it will have pre-shared key configured in the IPSEC attributes of tunnel group. The responder will also have a tunnel group and the pre-shared key configured here in the IPSEC attributes. Let's say I've purposefully chosen that the pre-shared keys are different, right? I want to show you something. So let's assume initiator has sent first packet, responder has sent the second one back, initiator has now sent the third message. Now responder should reply with the fourth packet, right? They should go. But before replying, before sending the fourth message, responder, because after sending, if the responder sends fourth message, what is the next step that it has to do? The next step will be the responder has to calculate session keys. And to calculate session keys, it needs pre-shared key. It needs to locate the pre-shared key, right? And to locate the pre-shared key, it has to first find the tunnel group. Once it finds the tunnel group, then only it can locate the pre-shared key. It sends the fourth message, it has to calculate the session keys. To calculate session keys, it needs to find pre-shared key. To find pre-shared key, it should find a tunnel group, right? If the responder finds that the pre-shared key is not configured, there is no pre-shared key configured here. It knows that it is, we are trying to establish VPN with 1.1.1, and it finds that there is a tunnel group with the name 1.1.1.1, and it's trying to locate the pre-shared key, but the pre-shared key has not been configured. So the responder does this thing before actually sending forth message, because it knows if I send forth message, then I will have to create session keys. To create session keys, I need to locate pre-shared key. To locate pre-shared key, I first need to find tunnel group, because pre-shared key will be in the tunnel group. So before even sending forth message, it says, let me first see if I have a pre-shared key. Because if I'm done sending forth message, then I will need to calculate session keys. So let me first see if pre-shared key has been configured or not. So it checks, it locates the tunnel group. The tunnel group is who is sending me these packets. Who sent me first packet? Who sent me third packet? So third packet came from 1.1.1.1. So it looks for, the tunnel group with that 1.1.1.1. So if it finds the tunnel group, then it checks, does the tunnel group have a pre-shared key? Has the pre-shared key been configured in the tunnel group? Say pre-shared key has been configured, then it will of course reply back. But if pre-shared key has not been configured in the tunnel group, it will not send forth message. This fourth packet will not be sent, because after sending fourth packet, what will it do? It cannot proceed further with the session keys because there is no pre-shared key configured. Then how will it tell the initiator that I cannot proceed further? If the fourth packet has already left, then how will it again tell the initiator that, hey bro, I don't have a pre-shared key configured, so I will not be able to calculate my session keys. So it does that, it checks that thing in advance. Do I have a pre-shared key configured? Or see, it's not checking if the pre-shared key matches with the pre-shared key of initiator or not. All it is doing is just checking, do I have a pre-shared key configured or not, so that I can calculate my session keys. They are not going to compare the pre-shared key yet, right? They're not sharing pre-shared key in fourth packet. Neither in third packet the initiator sent the pre-shared key. So pre-shared key has not been shared yet. 1, 2, 3, 4, these messages, they will not share pre-shared key. And even it is not sending forth message, so it could be because pre-shared key has not been configured. If it is incorrectly configured, because on that side we have Cisco and on this side we have 1, 2, 3, 4, 5, so they are different, but they should be same. At this point of time, they're not checking if the pre-shared key is a match or not. All it needs to know, do I have a pre-shared key configured? If the pre-shared key has not been configured here, then it will not send forth message, because after sending, it will not be able to perform the task that it has to do after sending the fourth message, which is to create session keys. It will not be able to proceed further. So the best step here is, let me not send the fourth message. That way initiator will know that something is wrong, correct? Otherwise, how will initiator come to know? If let's say responder doesn't do this thing, it doesn't check if pre-shared key is configured here or not, and it sends the fourth message, then how will initiator come to know that if there is a problem there or not? After sending fourth message, then he will try to locate pre-shared key, and it will not find pre-shared key because it's not there. It will not be able to generate session keys. So it's a waste of efforts. Why did you even send fourth message when you were not able to proceed? You should have checked this thing on first hand, right? Before you send fourth message. But that's why it is stopping fourth message right here, that I will not send fourth message, though it has enough information to send fourth message. But it knows that if I send fourth message, I do not have enough information to proceed further in calculation of session keys. So if pre-shared key is not configured, fourth message will not be sent. Another reason can be if tunnel group is itself not configured, right? Because pre-shared key is configured in tunnel group. So if tunnel group is not there, it can't find a pre-shared key for that, right? So there could be two possible reasons on the responder end. That one, the responder does not have tunnel group configured, and the second reason can be the tunnel group does not have pre-shared key configured. At this moment, it does not check if pre-shared key is same or not. All it cares about is if pre-shared key has been configured or not. I mean, if pre-shared key is different, that will be a problem at later point of time when they actually compare the pre-shared key in fifth and sixth message. But as of now, pre-shared key being different is not a problem as long as it is configured in the tunnel group. So two reasons: initiator, responder. Initiator has sent first message, responder has sent second message, initiator has sent third message, and it went into a state wait message 4. That means it's waiting for message 4 to be received. The responder is not sending message 4 because it does not have enough information to proceed after sending message 4. That means after sending message 4, what will be the responder doing? It will be generating session keys. To generate session keys, the responder needs pre-shared key. To find pre-shared key, it needs the tunnel group, right? So if tunnel group is not there, it will not send fourth message. If the tunnel group is there, but the pre-shared key has not been configured, it will not send fourth message. If pre-shared tunnel group is there, if tunnel group is there and pre-shared key has been configured, even if it is different, it will not care. It will send fourth message because it has located both tunnel group and pre-shared key, so it can continue generating session keys, right? So these are the possible reasons for your initiator to stay at wait message 4. So we are going to use this topology here where I have two sites. Let's say I'm given them some company's name. So these two sites, we have VPN between this ASA and this one here. These two devices will have VPN connectivity. The IP addresses are same as they are written, 67.1.13.142, and this ASA has a public IP of 2.2.2.2. I've already done the configuration, and I'm going to PC1 and doing a ping to PC2. Let's see what's the PC2 IP address is. So 192.168.10.1. Go back to PC1, 192.168.10.1. I'm doing a continuous ping so that I can see what happens on the ASA. So it's timeout. Let's go here on ASA1 and check the tunnel status. Show crypto ISIC MBSA. Because I've already done the configuration and I wanted to reproduce the problem and show it to you, so it's right there. The role is initiator and state at wait message 4. It's stuck at wait message 4 because I have continuous pings going on, so you are continuously seeing this. If I stop the ping, you will no longer see that state there, so I'll just go. So it's gone now. So why do we have this? The initiator says I am waiting for message 4. The initiator has sent. Why will it wait for message 4? Because initiator has sent third message to the responder and now it is waiting for fourth message. Why it is not getting fourth message back? Because there is some problem on responder end. Either it does not have a pre-shared key configured or it doesn't have a tunnel group. You may be thinking that I'm just saying this, right? Where is the proof? This is me telling that if you see wait message 4, that means these are the problems. You do not have either tunnel group or you do not have appreciate key. So, but how do we know, right? How do we know by ourselves? So you can do debugs. Let's do some debugs. Where do we do debugs? So we will do debugs. Where do you think is the problem? This guy has sent message 3. Initiator has sent message 3. It is waiting for message 4. So you will not find anything in debugs here because this guy is waiting for message 4, right? The problem is on the end who is not sending message 4. So we'll go to the responder end and we'll do debugs there. So I'm at responder end now. ASA2 is the responder. So let's apply some debugs here. Debug that I'm going to apply will be conditional debugs. So I'll say debug crypto condition peer and peer IP. So my peer IP is, let's go back here and do show IP. Peer IP is 63.113.142. Come back to SA2, paste the peer IP here. So I applied the conditional debugs, and that's what you need to do in your live environment if you have to do debugs for one particular tunnel. That's how you'll do it. So you'll say debug crypto condition peer IP, and then you'll say debug crypto ICAMP 128. 128 level gives enough information for you to figure out what is the problem. I go back to PC1 now and start the ping again. So yeah, 1 or 2 ping should be enough. I'm just going to stop them and go back and look at the debugs. So it's right there in front of you. It says, you can read it. No pre-shared key configured for group. Cannot find valid tunnel group. First it says no pre-shared key configured for the group. It says I found the group, but there is no pre-shared key configured. And then it says cannot find a valid tunnel group. So valid tunnel group will be when there is a valid pre-shared key configured. Right? So this device has a tunnel group, either a tunnel group missing or a pre-shared key missing. So most likely it looks like it says no pre-shared key configured. That means a pre-shared key is missing. So let's check that out. So we are looking for a tunnel group whose name should be this IP, right? Say show run tunnel group and the name. So tunnel group is configured, but you see there is no pre-shared key in it. So we have a pre-shared key missing. So let me just quickly configure the pre-shared key. So I say config T, go into the tunnel group config. So the pre-shared key will be in IPSEC attributes, and you have to say IKV1 pre-shared key. If you remember, how will you remember? The pre-shared key on ASA1 is Cisco 123, and pre-shared key on ASA2, I'm going to configure it different. Let's say school 123. So I've configured a different pre-shared key, but I've configured a pre-shared key, right? So pre-shared keys are different. Now we see what happens. It's going to end. Go to PC1, start the ping once again. Still says timeout. Go to ASA1, say show crypto ISIC MBSA. It's no longer at wait message 4. Now it's wait message 6, right? So we have get past that wait message 4 by configuring a valid pre-shared key. I'm not going to show you the debugs of ASA2 because those debugs are for wait message 6. So I don't want you to get confused at this moment. How did we fix wait message 4? There was a pre-shared key missing in the tunnel group configuration. Another reason I told you that if there is no valid tunnel group, so I'm going to go back to the ASA2 and delete the tunnel group, and then we reproduce the problem once again. Well, we have a tunnel group configured. Show run tunnel group. This is the tunnel group. I'm going to delete it. Config T, no tunnel group, IPsec attributes, and then no tunnel group. There should be no tunnel group now. Tunnel group config is cleared. The continuous ping is still going on, so go to ASA1 and do show crypto ISIC MBSA, and you see what? Again, it's wait message 4. So ASA1 has sent third packet. It's waiting for the fourth packet from ASA2, but ASA2 is not sending fourth message back because it knows if I send the fourth message back, then I will have to generate session keys. To generate session keys, I need pre-shared key. And where will I find the pre-shared key? In the tunnel group. So it's trying to find the tunnel group, but there is no tunnel group configured. So it says I will not send fourth message because then after sending fourth message, I'll not be able to proceed further. And we can confirm that with the debugs. So I say debug crypto ICCamp 128. I should say debugs. There. I'll just say undebug all. And it clearly says can't find a valid tunnel group about, right? So there is no valid tunnel group. That's why it's not sending message 4. There is no relation, no requirement of tunnel group or pre-shared key in message 4. It is not sending message 4 because after sending message 4, it needs to create session keys. To create session keys, it needs the pre-shared key. And without a tunnel group, it will not be able to find the pre-shared key. So that's why it's not sending message 4. That's the responder's way to let you know that there is a problem and I will not be able to proceed further. So when there is no tunnel group, it cannot proceed. So there are two problems that we have identified that can let your initiator stay at wait message 4. One, the responder does not have a valid tunnel group. And two, the responder does have a valid tunnel group, but it does not have pre-shared key configured. At this moment, it does not really check if the pre-shared key is same or not. So it should be configured there. Right? If you're seeing that your ASA is wait message 4, that does not mean that pre-shared keys are not same because it's not checking if the pre-shared key is same or not. In the next video, we will see about wait message 5.